Alright, hello and welcome. My name is Alexander Buczynski, and I will be teaching today on how to use Driveworks. So, here, as the user will be pointed to, once you start up the program, you'll be pointed to a screen where you can put in your employee ID and your password. This is mine, for instance, so if I go and input the data, I go and put in my password, you'll see, okay, this is my employee ID. The password is whatever the user has set before. I'm going to go ahead and say this is my first time since I'm going to be teaching. Alright, so we're going to continue. The first time welcome screen just explains to you the ideas and concepts of what you will be seeing. So, for instance, if you hover over certain items, you'll get an extra information, which you'll see throughout the entire program. There's an explanation for reporting an error. And here's a couple color codes that I'm using. Blue is like for information. This yellowish, whitish color, pale color, is a note. So, let's move on. So here is the important information. You enter your project number, you can select a revision number, what machine type is, and just like we were shown before with those overlay, those hovering ability, if you hover over those machine types, it'll tell you the max format range, forming depth, and extra additional information about that machine, which is very useful. And so you can just, by hovering your mouse over and just scrolling up and down, you can see those values. So I can select the TF1. I'll just select the TF1 for this particular project. So now, here's a save location. Usually this is copy and pasted, but here's the open folder dialog that shows if it actually completes and finds that location. So I'm just going to go to here to experiment 8. Let's go ahead and delete anything that was in there before, and I'm going to go ahead and copy that right there. So, okay, that's going to be the path where I want it to go. So I'm going to go ahead, and you can see right now the path is incorrect, so there's an error, and it will not let you proceed until you enter an appropriate location that's correct. So this checks it. You can go ahead and check. Yes, that's the correct folder. Okay, we're good to go. So here you can input a customer name, product name, so on and so forth. Okay, now next important part. Now we select which stations we want to drive. We can select to go and drive the base and lid, the blister card, forming tool, and the seal tool, along with the die punch. All these stations can be driven, and that will unlock extra windows like you'll see going on. So if I select only the base and lid and then blister card, it'll only show me the windows in the future, which are these ones here that talk to me about the cabby design, the products, and the card options. It won't go into designing the forming tool or anything because I haven't selected that to be driven. So those are going to be the options, and for right now we're just going to select the base and lid and the blister card. So moving on, we're going to go here, and is the product shape, where we can select what type of product we're going to drive, whether it's basically a convex, an oblong, whatever the shape may be. And that'll unlock all the variable names. Now, the variables are given here in these images. It's easy. You can click to enlarge that image if you want to see it better. And as you can see, the idea is that the user, which is us in this case, we are going to enter the values that we've taken and after we've measured our product. So these values already have some values here that I've put in, and we're going to use those values, and that's fine. Now, just to show, if let's say we were driving a capsule instead, you can go ahead and select this value. And these are going to be, if we wanted to use a standard capsule dimension, if I select, let's say, a 00 capsule, those are going to be the values that are automatically, that I have given in the table, so you don't have to look those up. Those are values that are standard sizes for those capsules. So if you select them, and then if you want to customize them, of course, you can input your own values, which would be, actually that'd be insane, so let's just go with 0.5 and a lock length of 20. That's pretty much similar. Now if you had values that were very close, so let's say this one was 10.36 and 26.4, let's say we went with something that was like 10.3 and this was 26.2. This will automatically suggest a capsule size, which is very nice because if somebody doesn't realize that there's already a standard size, the designer will automatically get prompted by the program to go ahead and select that. And if I do, it'll select that standard capsule size. So let's not go with the capsules. Let's go back over here to tablets. And let's go to an oblong convex tablet here. So I have already entered here some dimensions. So here's my thickness, my width, and my length. let's go ahead and go to, that's an oblong shape. Alright, the thickness was that value there. Let's go ahead and copy this, put that in for the width. And you're seeing right now an error too, which is telling me that, first of all, it can't be greater than 0, so let's just put in 1 just to show. There still will be an error that says that the width cannot be greater than or equal to the depth, and or length in this case. And that makes sense because if, for instance, this width was going to be greater than the length here, you'd have geometry that would be overlapping and bisecting each other. And it just doesn't make sense. So by convention, we are going to say that the length is going to be longer, and that's given by this graphic up here. It'd be pretty hard to mess that up. But just in case, there are checks and balances that make sure for that. So, okay, now this is given the radius here, automatically calculated for us. That's a very easy thing to figure out. So now we come to the manual entering part. So here the user sees all the values that Driveworks automatically calculated. If for some reason any of these values need to change, they can be changed by going here and selecting the customize option, and then the user can go and select a different value that hasn't been calculated. So let's say instead of making 18.8, we're going to round up to 18.9. Whatever those values are, the user can then choose that. So those customized buttons are there in case the program comes up with something that the user doesn't agree with. And so all those values are given here, depending, and this changes depending on which product we're using. So that gives the options what we need to select. So then the user can select a draft angle, whatever those values are, and then this is this tolerance, which is used anywhere from 1.2 to 1.6, and you can see that those values are adjusting accordingly as well. So we're going to go ahead and go with what Driveworks automatically calculated, and let's change this to 0.75 millimeters. Okay, we have something a little bit different. So next, we're going to go ahead and select our card type. So here is, Driveworks is going to say this is the minimum card width, in this case, in order to satisfy the criteria that there is a 4 millimeter displacement between the halos. So the gap between halos should be 4 millimeters, and that's going to be this value. Same as if you wanted something that's maybe a 2 millimeter displacement, then you go down here, and this is the value for 2 millimeters instead. So if you wanted to know that. Now a nice thing is if we go ahead and select the standard button, these values will automatically just be rounded up, so you have nice values here. Also, like I've said before with the hovering, if you hover over those values, it also tells you, because this is a TF1 machine, that's going to be our max values in the X and Y dimensions for our card. So I'm going to go ahead and select custom because we never would want an actual standard displacement, like a card length that's 73.6, because we'd rather have something that's rounded up. Less significant digits are better. So here's a cavity rotation feature. Let's go through that. Cavity rotation feature allows you to rotate that cavity about the center axis. So if I wanted, let's say, this tablet here to be at a 45-degree angle so that they would show up on the cards, I go ahead and select here, okay, 45 degrees, and go ahead and press enter. And you'll see all those values automatically changed. Okay, and they're all, of course, the same because it is a 45-degree angle. Anyway, now we can see those values change, but I want them all to be, if it's at 0, for instance, that means that they haven't changed. They're going to be your X in this direction and your Y is going to be the same. Now, if I went to 90, of course, those will both flip, and that's why you see those values there. So go to 0, 73.6 on that side. Go to 90. Now it switches to the X, 73.6. So this will now allow us to select different options. So if I went and said 5 or 6 cavities, whatever those are, I only generated images for up to 5 because I didn't want to add more. It took a lot of time, to be honest. So let's say I wanted 5, you'll see those values also change. So the point is, any of these options you change here, you'll see that updates. Now let's say I went out of the range of what is actually possible. Like we're only allowed 130 millimeters. So let's say this goes up to 152 here. I select this, it'll give me an error and says, hey, your card length exceeds the maximum value. Go over here to customize, I go in and I say, let's say 160. Driveworks won't allow me to do anything about that. If this is a nuisance, we can go and later on in a later revision change that. But as of right now, that's been included just to check that nobody goes above that value. So this actually wouldn't work in this case, and you'll see that the halo gap would be extremely small. That would be like 0.733 millimeters, which is insane. It's way too small. Now, that can be adjusted, and if we wanted to, we could go and mess with those values if we want, and that's up to the user to adjust for those, but we're not going to for right now. So what we're going to do is we're going to go with the 4x4 that I had selected originally, and let's go standard here. I'm going to round this up to an 80 millimeter card, and this one I'm going to go with a 100 millimeter, and let's see what those values are. Alright, well my halo gap is 3.3, it's a little bit too small. Let's go with 1.05, and let's just see what that looks like. Okay, that's fine. 4.35, 5.28, good, I like that, that's nice. So let's then move on from here. And also, if there ever is an error that you don't like, you can always press the bypass button, and that will be later a report is filed with Driveworks, and it will let you know that you selected that, but it is there in case I have an error in there that you don't like. So one thing before I move on, there is the ability to add a perforation cut, and if you do that, it'll change the sizing, displacement, everything changes if you do that. But we're going to go ahead and set up no perf cuts for now. So now here comes the next part. We're going to now have to specify the blister card is already given, which is that length was 105, which we put in before. Then it's going to automatically suggest a form material width and a lid material width as well. And in this case, that's going to also then determine our scrap and our vertical scrap. By default, it's set to be 5 millimeter scrap and 3 millimeter scrap between the lid and compared to the base. So you can, of course, go ahead and press customize, and then all those values unlock. We can change that to, let's say, 120. And you'd see, okay, scrap is 7.5. All right, let's go with that. I like that. So in the future, I plan on having an actual list of in-house materials, but because we don't actually have any information on things like tensile strength or any real information on the material we have, because they're all polymer composites, and we have no real testing on it, I right now have just a general list that I took from a manufacturing process for engineering materials textbook, something that I have had used in my studies, and so that's what I've been using for those values, and you'll see here the tensile strength change, as you see, and I just put in some default values just to show. But normally what will happen is we're going to use this customize option. We can go ahead and tell the name of the material. You can put this in. This is not actually changing anything. This would be more for the die punch to figure out how much force is exerted in order to shear the card that you're trying to punch out. So that's in there later on. You don't actually have to input this information if you're in our situation where we're just using driving the web and the blister card. So I'm just going to go ahead and use a uniform shrink factor, which is something used later on, but they show up on the card, so we're going to put that in. Here's a lid material. We can give it a name as well, and then if you want to put the tensile strength, you can do that. This is for aluminum, stock aluminum, like 6061. That's what I have currently right in there, but of course you can change it, and your mileage may vary. You can put what you want. So now we're going to go up here. This is the preview button. When I press that preview button, now we will be able to see a generated model from Driveworks. It takes about anywhere between 30 to 45 seconds, depending on how fast your computer is and the network connection. But in my experience, it's been about that time. And of course, your mileage may vary when it comes to that, but it's something that it's going to be about that time anyway. So now I'm going to wait until that finishes, and then I will talk about the card. Okay, so it just finished. Let's go ahead and go here and take a front view. So here's our card. Here is the product that's been generated. And here's the card that's been that layout. We have that 90-degree rotation. This is, this is the standard. X in this direction, Y in that way. So we just rotated, now it's 90 degrees and it's changed. So now here's some things that are important to look at. Let's go back here and look at those calculated values. We said that the halo gap was about 4.4, let's say we round up, in the Y direction. So that would be between this value and this value. Let me go ahead and clear those selections. I didn't do too good of a job selecting those. There we go. 4.35, that's exactly correct. So those are those values there. Check the value of displacement between these points. It's 5.28, correct? So we know that it's definitely working. And a couple other things to denote as well. If I go back here and you see the theoretical sharp points on both of those, let's go ahead and open up the part and go to that drawing. So if we go in here, we can go ahead and edit the sketch. Let's go normal to it and look at it. So from here, we can see, okay, the TSP was 11.4 this direction, and we had a draft angle of 5 degrees, which is actually then double that, going from both sides. And then the depth, cavity depth, is 5.362. If we want to change that, let's say that's too specific, let's go with 5.4. And I'm going to go back to it. I'll show you some things here as well. Let's say I said this is 11.4. Let's make that 11.5, a little bit greater. And then let's go with draft angle, let's say 4 degrees. Okay, and let me just rerun this and I'll preview it again. So now it's going to run again, and going to go back to the main assembly. So we can go back and switch between the part and the main assembly, and it's an easy thing to switch back and forth. But whenever it previews and drives dimensions, you don't have to drive everything again because everything's loaded. It only has to drive, in this case, the few things that you changed. So for whatever reason, my mouse isn't working here, so I cannot scroll. So, okay. Let's go here, open that part again. There we go. Alright. So now we can see, exit out of this, discard changes. Exit out of this. And I think I just did exactly what I was trying to hinder from. So, because I had the drawing open and I pressed preview, SolidWorks was actually handling the changes. So I couldn't, Driveworks couldn't take over. So the best practice is to exit out of parts and just go back to the main assembly whenever you want something to change, and then go back and open that part. So let's go in here. Let's go along cavity. You can see 11.5 is this distance, and the cavity depth should be 5.4, but it's not. So there's an error in my code somewhere that doesn't override that value. So what I'm going to do here is I'm going to say report an error. And I can say I discovered an error here, and I'm going to go ahead and add a screenshot. Hold on, let me move this over a little bit. Make a new screenshot. Those values. It's already copied. I'm just going to paste it right there. This is good. That's the point. There are errors in my code, and it does happen. So when these things happen, and when this type of error occurs, I'm going to say I discovered an error, and the cavity depth does not change after customization is selected. There we go. So now I'm going to go ahead and send that. And there, I'm going to cancel out this. I will fix that later. So that's a perfect example of exactly what I'm trying to show, is that if something goes wrong, please let me know, because it will. And there were things like that. So it's a simple thing for me to change, but if I don't have enough experience testing everything, it's easier to show. So what should have happened is this should have been 5.4, just like this value changed 11.5, and that draft angle changed to 4 times 2, 8 degrees. So that's the point of what Driveworks does. It generates a model very quickly for you. So just to show a couple other things to drastically change this, let's go to 45-degree angle. Let's make it 5 columns. And go ahead and select standard. Alright, this is too wide. Let's go with, let's say, a 3 layout, and let's add a perforation now. Let's see what that looks like. Alright, now it's going to make that too long, so that doesn't work, so let's just go with this. That's fine, and let's go 2, and put in an unsealed area strip, which is going to be, let's say go with 10 millimeters between the two. We'll keep the center perforation in there, and then, okay, that checks out, that's good. Alright, let's go ahead and preview that. Let's exit, nope, we can stay in here, that's fine. Now let's go ahead and preview it. Alright, now let's look at this card. Wow, very quickly everything's changed. The angle is different. Now we have there's no perforation lines anywhere. But what we do have now is we have an unsealed area right here between those two values. And the interesting part is that we can go here and check what that distance is. And we show that, okay, everything works out. So we should be good. So now the biggest thing that we should check is that there should be a 4 millimeter gap here, which it is. There's 4 millimeters there. That worked out. And just as a side note, this was a pain to program to get this to work with any angle that we have, but it's there. So now I'm going to go ahead and customize this. 65, let's make it 120. Alright, good. So that works. Okay, so let's go and look at a couple other things for right now. I'm going to go in here. This is the web layout. Okay, so now what we're going to do is I'm going to go ahead and say, alright, I'm happy with that. I'm going to go and finish this document. Now it's going to go and give me options here. I can go and save the models. I can also generate the drawings and generate documents. There's no documents that will be generated, so for right now we'll just generate the drawings and the models. Let's go ahead and press finish. Let's see what happens here. Now in that folder location that we had opened before, this is where it's going to dump all those files, and you'll start seeing them show up here in a couple seconds. What it's going to do is, given the codes for these files, it will now say the product number, which is what we had inputted before, the particular build, and then going to give the general names and everything that is standard for tooling, and as well as any other codes that we have. So it's going to be generated, and you're going to see here, okay, this window just popped up. This is a report. When you open that report from Driveworks, this will tell you if there were any errors that were encountered. And just by a brief overlook here, we can see that there were no warnings and no big red errors that actually occurred. So nothing that is where it failed to drive a dimension. So that's great. Let's go ahead and look at the other report as well. And this one, which is for the drawings, there's separate ones. There's one for drawings and then there's one for models. So here we saw that there was one error, that was a warning at least. And here, we're going to look here and see what happened. There is a view position error. No values have been entered for view position. And in this case, this is where, let's say, there were no values entered, so it just says, okay, we're going to go with whatever was default. And this is not something to be concerned about. The only things that ever really are concerned is if there are a report where the actual errors occurred, not warnings. Warnings are something that Driveworks can fix. So let's move on. Let's go ahead and open that drawing that was generated. Let's go to sheet 1. And the reason why I'm showing this is to show what Driveworks is actually capable of doing compared to what the user will have to edit afterwards. So what Driveworks will do is it's going to input the information, who was drawn by. In this case, it's me, Alexander Buczynski. And I'm going to have a little, in parentheses, there's a little denotation here that says this was designed in Driveworks. So the point of that is that then the user and anybody knows this was generated in Driveworks, and also who had designed it and what was using it. And if someone wants to change it when the final release is, they're more than happy to go and put their name in or whatever. So this tells you the date, when it was created. Here is the product information and the customer, all the stuff that was entered originally when we started off. As well as I've also included a shrink factor denotion on there, which is I think is just nice to have. Okay, so moving on. What we're going to see here is a couple of things. The card length and or width and length are automatically going to be put on there, but things like your theoretical sharp point and that distance is not going to be automatically included, and also like your ordinate dimensions here. These values, it's easy to add. You will have to add them. So if I wanted to find, this case is going to be kind of an interesting example because we don't actually have it's all at these odd angles. If that's the case, you might as well go ahead and delete these or adjust them, which I can do here. And it's a simple thing is editing a sketch and then just orientating and making it collinear with that point, and then you've got it, and that's easy to do. So I'm not going to do that for the sake of this tutorial. It's simple enough, and any designer knows how to do that. So the values though here will be given, so you will get your index, your blister length, all of this is automatically included. There's nothing that has to be done by the user. I mean, maybe some spacing generally. Maybe grab that point and move it around a little bit. Besides that, there shouldn't be too much to be done there. Everything else is automatically created. You will have to enter, like I said, the theoretical sharp point, your draft angle, just you need to select different values, or rather select the two different edges, and that'll take care of that for you. So, and then this also includes that product, and it's pretty easy to add those dimensions. They're not included immediately, but it's not showing what I want to show here. Here, here. That's like that dimension. Very good. And alright. Well, there we go. That's what I wanted to show. Alright, so then all those values are already included. And that's what we saw before. Actually, we go on that note. It's interesting to look at. 16.5, width 4.9, radius is that's 0.3, but and the width was 8.5. There we go. So those are all those values right there, and that corresponds to that. So that's already done. So that's how we create drawings. All those files are then already created here, and that's this is basically concludes an overview of just creating a blister card and the associated web layout. And that's it. So anyway, thank you very much for listening and paying attention. And this is the conclusion of how to use Driveworks to automate your design for creating web layouts and blister cards. Thank you very much.